Okay, we're back. I'm going to do a battery swap. Okay, so if you start new, we got the case all centered up this way now, all the way around. Goes around this side here. A little bit out of roundness right through here. Boom, boom, boom. 5 thou jump. So you look at the averages, boom. Got a 3 thou jump on the half. Then we got the deck squared, table squared, head squared, everything squared. Okay, so now we're going to bore a hole. Now, all you want to do is here, we're going to bore this lip out that's right down in here. We are not going to bore the spigot bigger. We're just going to get rid of this lip that's in there, and then we're going to go ahead and cut this whole thing out on this side. Now you hit that with a big hammer and break it out, which really makes it look like crap. And you can break the case in more than one spot where you don't want it to break, so not a good way of doing it. You can cut out and grind out by hand, which works too. It would have been a hell of a lot quicker than this, but oh well. It also looks like you did it that way, which is fine if that's what you're after. Let's see, this one should work. Okay, this is a boring head here. It's a 3-inch one. It's 3 inches across. So on the smaller bore motor, this will work fine. When you move to a bigger bore motor, you need a bigger head. So it's a 4-inch boring head. It's 4 inches across. 1 inch doesn't sound like much, but big difference between 1 inch. 2 inches like half the size of this one. So it makes a big difference. They also charge a big difference. Imagine that. Alright, so this one here, you can bore a hole up to with a 3.5 inch motor with this, so that's about 3 3/4 spigot diameter, but if you got a face off the top of the case here, this starts getting to be too damn small. So that's when you use the bigger one. But for this application, this one here is fine. Appear to be too high in the air. What a shocker. Okay, usually go down to where it'll clear just by sitting straight up and down. Yeah, about like that. So that's what I use for boring bar. This is actually a 3/4 boring bar out of my lathe, or using a lathe, but also this is actually one for doing a boring head. You can use either one. This one here I shortened probably 2 or 3 inches. It was way longer than I needed. So this is the perfect height for what I need. So every job varies slightly. So right now we're too big to go in here. We're hitting on the back side. So I'm going to unadjust this a little bit. Or I need to drop it a little bit. One or the other. Okay, fit in the hole that time. Alright. Go until you touch. Back it up a little bit. What number are we on here? Dark over here. Let's see, that's 80. I heard it hit over here. Hit now though. 70s, I don't want to go any bigger than 70, probably. Which is about right here. And I want to make an initial cut that's less than my final, so I'm going to back it up 50, 100, come back. So that's about 60 right now on the dial. Let's get a starting point. we should be able to power it right on through. I need to go ahead and set my depth stop, so you go down until you clear everything. Make sure there's nothing sticking out under there to hit. And you set the power stop. You stop up here. There's your stop. When it hits that, it, the lever pops and disengages. Power feed. And basically start about right in that area. Okay, so we always want to bring it up when you first crank it up. See where you're at. And we go from there. So right now we're only doing about 600 RPM, which is pretty low for the boring. On this machine here and with this boring head, I can bore up to 1500 RPM, works fine. With this one here, 1200 works about right. With this one over here, it likes 1500. Different harmonics. So you gotta make sure you spin this the right direction. That appears to be right. That's way too slow. So we crank this up right here. Spin on up, there's 12. It's a lot better. I always like the blank range. Yeah, right there. That's probably more about 1350. Okay, we're not hitting anything. Still not hitting. That's good. Okay, we've got about this much more to go, so we should start hitting. So now it's feeding down. Past, so I can raise that up a notch. Okay, that was a nice light cut. I think that was about 100th out of the side. It's a light cut. I only got 100 to go, so. Okay, so there's that one, and we're gonna go, there's 30. We should have clearance to 70, so we'll see. Engage it. Keep feeding. Don't put your hand in there right now. Hit the brake first. Okay. Realistically, that's all we really need to do. But we might as well go a little close. We got a boring bar here. We can go closer. Okay, so what number am I up to? I think I'm good to 70, so I'm gonna go to 60. I just don't want to cut the the wall out here. So now, when you crank this thing up, it goes out a little extra, so you gotta be careful. We're not hitting yet, so we're good. See how close we are now. Okay. You can see the lip is pretty small in there right now. Okay, that was 60. I'm thinking we're good to 75-ish before we hit. There's 70. We're hitting somewhere in here. There it is. See, we're just whiskering it right over here. The only place we're hitting appears to be the only place we're hitting. I think I'm off by 1 thou. Not 4 thou, dumbass. Damn, Jesus. Yeah, 1 thou. Yeah, somebody wants me. Just like it. Alright, here's our cut. We just whiskered it somewhere right in here. So we'll be back. Okay, I got the whole board. So now it's just about identical size, slightly different but close. The only place I hit was right up in here, and I just thinking why it was hitting there, because I got the deck angled like this a little bit, so that's why it touched over there. Be my guess. No, I was hitting over here just slightly too. Here you can see the wisp mark right here too. See how it's shiny there, not shiny here. See, it's the outer roundness of the hole. So that's how close I was to the size. So I'm within a couple of thou of what I needed. It would have started cutting. So, all right. All right, I'm gonna go ahead and swap this around, rotate it up, and get the other hole cut. Flying right along now. We'll see how far that goes. First thing to do is pull that out. Pull off that. Okay, I'm going to rotate it. Okay, we're going to hit against anything down there. Looks like we're going to be clear. Go. Put on the other side of the dowel pin, get better pressure where I want it. Alright, looks good. Oh, dumbass. Okay, I'm going to square it up. Not even close. Zero. It says 6 out. Let's see what that really is. Maybe I'll have to shim it again. Let's see. Make sure everything's hitting where it belongs. Yep, all looks good. Pressure on there. Looks good. Okay. Nothing foul different than the side to side right now. Okay. Tag anything. All right. Two tile off from the level. Trying to go up. Jeez. Two tile difference from side to side there, huh? Average is the same. A little bit higher. And our variance in this way is about 7 that way. And we're about 8. 1 thou. See, old junk Harley military cases are better than brand new shovelhead cases. There you go. Just because they have old doesn't mean it's not machined correctly. Back in the day, they actually knew how to cut metal. 80s, they didn't care. That's better than new twin cam cases too with CNC equipment. Them things are 3 thou out every time you measure them. But every now and then one comes in correct. It's rare, but it does happen. Yep, what do we have here? These off. That shim makes a difference here. 7/8, 7/8, or not 7/8, that's getting 12, 13. That's 13 to 15. Off to about 10. Yeah. It's an average out of there. Overall, it's pretty even there. So we moved it 3.2 thou. So that 3 thou shim over here kicked us over 3.2 from that other deck. So that's pretty damn. That means they're pretty damn close. If I didn't have the shim, probably within half a thou. Pretty good, or at least a thou. That's pretty good. Once again, the old stuff's machined nicely. Okay, drag on that. Okay. Need to go ahead and cut the hole out now. time I'm going to put the boring bar in the center of the boring bar. So I got to bore out the whole thing, not just the outside edge. Go all the way through. Probably about there. Okay, so I'm going to bore out the whole web assembly. So I'm going to make some big cuts initially. First thing I do is get this zeroed out. Yeah, we're at 5, that's close enough, 95. Okay, I'm going to go ahead and feed it down right now and cut through there. So that's going to be our first cut. Back up a little. Okay, that was about a quarter, 200 thou cut on both sides. That's a 400 thou cut. Okay, so each turn this is 100 thou. There's 50, 100, 50, 200. And we're going to zero it. So now our zero is right there. So that's a 200 thou pass. So that means we're going to cut 100 wall. So there's going to be 100 thou coming off that one spot right there. See how the left side here is higher than the right, but in the real world, this is the right side, this is the left. But you always look at a motor as if you're sitting on the bike. So right now where the front end is. So the right side of the case is quite a bit higher than the left by about 50 thou at least. But that's just because it's a raw casting, so it doesn't really matter. Okay, I'm going to keep doing these little minor cuts. 200 passes. I could probably do 300 if I wanted, but it's good enough. It'll come out quick enough this way. Now the bigger this gets in diameter, the more this cut is. More areas, more metal it's removing. So at some point we'll drop back to 100. If we're good. A lot of chips coming out. It doesn't take long to do it this way. 50. Advantage of the power feed. Number 2. Where's my zero at? What happened? Oh, there's my zero. Lost it. Sloppy. Make sure you don't hit anything. Flip it on, power it. Feeding. Okay, so that's the last of the big thick cast centerpiece. 2. Where's my number at? What the hell's going on here? 0. The more this moves out, the more it's going to start vibrating. Called out of balance. Now, where am I at here? I think I'm 3. Yep, 4th one right there, 0. I'll just drop back to 100 thou passes, I think, after this one. F1. 100 thou pass. I can do this one more time. Just swap the bit around. Getting a lot of overhang out here now. So these are 50 thou passes now, 50 thou per side, 50 wall, whatever you want to call it. Good for one more. I said that last time, though, didn't I? Need to crank this all the way back in now. Tiring. Okay, where's 0 at? Yeah, good question. About there. Yep, that's a good pass. Alright, reset our cutter. Take another pass. Looks like another 100. So even though I flipped everything around, 100 is still 100. Too many more of these left. one more of those to go, and then that's it for the hundreds. Just start slowing it down. Okay, we're going to wind up at 70 as our finish. So I'm going to go around to, there's 50. Make sure I don't hit anything. Nope, cutting clean. Just started cutting on this side over here. Started cutting right there, so heard it. That's that big lip in there. Pretty good right there. Give it a little extra. Kick this over 1,000 right here on the table. It's at 1, not 3. 1.1. Okay, that should get it off this edge. Should cut over here. Actually, I didn't go enough. I cut it. That needs to go about to 2. Two and a half, close enough. Yeah, let's see where it hits this time. Cutting somewhere. Cutting over in the back corner over there. Just cut that corner. Not cutting this corner. So 2.5 is too far. Go back down to under 2. 1/8. Try that. It's fogging that back edge. Trying to catch that area. Yeah, it's just cutting on this side too. You can see the reflection all right. So the case is out around oval shape slightly. We'll clean that up. There it goes. A little bit too much speed for the lack of load. Where the shadow comes from. I slowed it down a little bit when I've done that. Okay, so you can see I was just skimming along the wall here. Just kind of marking it, not really cutting it. Cut a little bit there, but not too bad. Once you got down to this area, it started cutting. And on this side, it did exactly the same thing on this side. It's not cutting here. Cut a little bit right in here. You can see how it's just kind of fogging all the way over to about my finger was right to there. Now every time you bolt a set of cases in, these 3 dowels, this one and these 2 down here on the bottom, these set the rotation of the case. And you never go back identical every time. So right now we had a 2 thou variance at most between the two. because we're getting about three to five variable number. So if you're one thou off in that, it'll doubles on you. So right now this kind of equalized some of that out of it, but the decks in here had more clearance. The cylinders had more clearance in the spigot than what the air in the case was, so it didn't cause any problem. It does cause a problem in the height variance between the two cases, though. That's why they have gaskets. It takes up that 1-2 thou difference you get. So, but anyway, that's how they do that. Now later on, I'm going to come back. I'll deburr this from the other side, but we also got to cut the stroker clearance. But for this part of the job, we got the spigots completely bored out, and it's a nice clean cut. Takes a lot longer to do it this way, but I like doing precision work, so there you go. Okay, so now we got this case is done. So this is this is what the 41 WLD. So the next case is the 42 WLA, which is the other one. So that's the one laying over here. So tomorrow I'll get to that one, and I got to swap all the hardware around to use it on that one. I'm using the same hardware on both cases. So, all right, that's it for now. It is time to hit the road. So we'll get this all cleaned up. Be back tomorrow.